Hello, guys, and welcome to our next workshop in our Cybersecurity Cybertruck Workshop Series edition. And today we're going to be discussing Nmap. For those who have not heard of Nmap who have not downloaded Nmap, please do so now. For Mac, it's brew install Nmap, or on Linux, it's apt install Nmap. For Windows, I think you can download it from the website nmap.org. I believe so. So let's get started. So a quick disclaimer. The following video may or may not contain tools and techniques used by hackers to penetrate and affect computer systems, servers, and personal mobile devices. The purpose of these videos is to determine how these attacks work so that you can protect yourself from them, also to raise awareness of important cybersecurity issues in today's world. Techniques and tools learned from this video should only be performed on systems you have explicit permission to do so. UC Merced, Q Project, Tech Equation Inc., nor the presenter or all my affiliates are not responsible for any malicious use of this information. So let's get started. What exactly is Nmap? So Nmap is a free and open source utility for network discovery and security auditing. There are multiple tasks you can accomplish with Nmap, and some of them include network inventory. You can also manage service upgrade schedules. You can monitor host or any service uptime for specific hosts. Nmap uses its own raw IP packets to determine a variety of characteristics of the host. For example, Nmap may you can use Nmap to find out what hosts are up in the network. You can use Nmap to find out what ports are open on that specific host, and specifically what services the hosts are offering through those open ports, as well as any kind of packet fire filters or firewalls that are in use. And there's a lot more characteristics that you can use with Nmap. It's a big tool, and it's very popular, and especially because it's free, it's often well documented, and it's um, you can build upon the actual source code of Nmap because it's open source. So I'm going to go in the next couple of slides. I'm showing some snippets of some Nmap cheat sheets I found online. They'll be cited in the works cited as always at the end of this. So I just wanted to go through multiple ones. So right here we have the basic command Nmap. Then we have some sort of scan type, which is often denoted by a bunch of or scan type as well as options, which are denoted by dash and then whatever flag options. We'll go into that a little bit later. And then we do targets. For targets, there's different target types, or you can enter a IPv4 address, an IPv6 address. You can type in the host name itself. Of course, it uses DNS lookup to translate that host name into an IP address. You can also specify a IP address range. This is definitely used for host discovery on a certain network. For example, you're on your home network and you see all the hosts. You can use an IP address range. You can add the IP address range as a Cider block. Basically, get all this Cider block notation is the same thing as this IP address range. The 16 denotes the first 16 bits, which are these two zeros. So basically, 0 to 255 different addresses. Oh, 255 times 255. That's how many addresses this can take up, or that you're trying to scan. You can also if you have a specific set of IP addresses that you want to scan, you can put that in a file and use the options -il and then put your file name there to scan all those list of specific IP addresses that you have. Now, this is another target specification portion of another cheat sheet. I wanted to share this because it's pretty much similar to the last one, but also you can scan. I want to show the last two right here. One of them is IR. So 100 denotes the number of random hosts you can scan. So for Nmap, you can actually scan just random hosts. You can also exclude specific hosts that are listed. For example, if you do a range from you do range for your entire network, but you want to exclude the router, then you can put exclude there, exclude your router IP address. There's another portion on port specification. Usually, a host will have all of its ports closed because it's a cybersecurity vulnerability for having a ports open for no specific reason, because people can just send stuff to you through some sort of packet, and then the host accepts it and then runs that packet or whatever data is there, executes that data, and that's harmful because you can basically make another host do something else. And so when you open a port, it's usually for a specific service, and there's some common ports. Does anyone in the audience know some common ports and for what services?
I know port 80 for HTTP, then port 22 for SSH, and then what is it, like 53 for DNS? How many do you want me to name?
That's good. That's good.
Okay,
Thank you,
okay.
Solomon. Um, does anyone know the port for HTTPS? That's a quiz.
I think it's like 620 something, or I don't remember exactly.
I believe it's 443.
Okay, so I was off. But
That's fine. No, that's fine. I may be wrong myself, but basically you can scan a specific set of ports. Like for example, if you see a host and you want to see if that host is running a specific service, maybe, or you can check for specific ports. For example, you can force HTTP to run on port 80 or port 8888, right? It doesn't matter. So you can scan by the service name. You're just looking for HTTP because you probably have a packet or a malicious packet of HTTP that you want to inject into the host. There's also Nmap has a database of top ports, and so you can scan the top 2,000 ports. There's also port ranges. You can scan um, different ports in terms using different protocols, TCP or UDP. Um, there are different protocols used for different services, and we have at the very end you can make the scan go through all possible port numbers from all the way from 1 to 6,000 or 65,535 ports. That is the maximum. Oh, that's the maximum number that your port number can go to on a host. Now, for host discovery, you can look into finding what kind of hosts are there in your network. Um, for the first one, you can just list all the targets that were found that gave you a reply. Sometimes what firewalls will do to block this Nmap program from scanning you is drop the packets. And those are often like pings that they drop. And so to avoid that, you can do um, -pn. That disables the host discovery. So it doesn't ping it. It just sends specific TCP/IP packets for capturing those services, which is basically what the um, host is looking for when it opens a port. It's listening for specific service connections. There's also some other parts options you can do relating to host discovery. Here's some scan techniques. Sometimes um, it you have to know a little bit about networks, how networks work, specifically TCP and UDP, in order to use these scans. So basically, um, there's a difference between UDP and TCP. UDP is basically sending packets. Um, it's meant for like video and streaming services where you need packets as fast as they come. TCP is meant for like files and reliable delivery over the network, and often it has different uh, concepts such as send, ACK, Windows, and so all of these are leveraged by Nmap to do specific types of scans relating to the attributes of that specific protocol, such as TCP. And this is another uh, scanning type portion of a cheat sheet. You can do ping scans, you can do UDP scans, you can do XMOS scans, and just a bunch of different scans. This is another one. There's also ICMP, echo ping. That's when you do ping google.com, you're sending ICMP packets. So you can do the same thing with Nmap. You can also trace out your IP within Nmap itself. Also, this is a big um, flag used in with Nmap SV. Basically, you can try to find the version of the service running on the port. Does anyone know why we want to find the version of the service if we are penetration testers?
By service, what service are we talking about?
Like SSH is a service.
Oh, the different. Okay. Yeah, it would probably just be useful to know, like, if you're looking at something with an outdated service or not.
Exactly. If it's outdated, then it's vulnerable. Now you also got different OSs here, OS version detection, and with that you'll be able to do the same thing. See if it's outdated, if it needs an update. You can um, find online any CVEs and just inject packets from there. There's also timing options. Nmap takes a long time to run for specific IPs, and so you have different timing options. There's T0 all the way to T5. T5 is meant for if you have like a very fast network and you don't have any firewalls on a network that will um, trigger and shoot you down, or basically shoot the program down. T0 is meant for something like uh, you want to be very, or you want to be very um, careful about what kind of packets are injected into the network, because maybe you have a scanning firewall open and you want to actually get into the system and scan the host without triggering any fail safes by any cyber antivirus system that's placed on the network. Nmap also has a database of different scripts that you can brute force with any um, type of service. For example, there's the um, SMB boots script. There's DNS. Um, what do you call it? There's a DNS script that you can pull like specific zones from an actual DNS server. There's also different um, robots.txt that they harvested to actually find the um, robots.txt files from the actual web page. Oops. So there's a bunch of scripts. You can definitely check them out. They're actually built into Nmap. Now we're going to do a demo, but before that, here's my works cited. Now, welcome to the most amazing demo. So here we have this. I scanned the network, scanme.nmap.org. So go ahead and type this in your terminal. You'll see that the latency for each packet is 1.1 seconds. And I found different ports running on specific protocols. What state it is, open, filtered, or closed. And then you have the service, like what's running, SSH, SMTP. I think this is the email domain. There's NetBIOS, there's Microsoft DS. This is meant for this is used for remote desktop or just Microsoft services when you're talking to a Windows computer. Nping, Echo, there's Elite. There's some other services here. So you can see that this scan right here took me that long right there. And even when I'm trying to scan my own NVIDIA Jetson from my Mac, I can see that it takes the same amount of time. So you can tell that it's not the latency, but rather the amount of packets that are being sent to the actual host that takes a long time. This is my NVIDIA NGX Jetson. So you can see SSH is running because, of course, I need SSH into it. And then a service called RPC bind. What's something else you can do is actually, you can do Nmap localhost. And this is pretty fast. Like I scanned in 0.10 seconds. So if I run it again, it's about the same. Now let's try to put different timings. Let's say T5. Okay, let's try T0. Yeah, this might be pretty too slow. I can see that I have a domain name service open at 53. I have my Microsoft remote desktop open. That's what's using this. And I have an FTP proxy running. So while that's running, I'm going to go to my NGX and run Nmap localhost. You can see it's the same ports right here, but instead of 1000 seconds, it ran in 0.30 seconds. Now we want to, let's say, find the host. We'll find what service is running. So we can do SV. And let's see what this spits out. We can see the version of SSH is OpenSSH 7.6 P1, and it's running on Ubuntu. You can see that RCP bind, it's version 2.24, and the service info, it's the operating system is Linux, and the CPE is it's the Linux kernel basically. So so that's what we have. Let's see. See, this is still taking a long time. Let's try T4. Let's try T3, T2. Okay. Hopefully it doesn't take too long. This is scan me nmap. So we'll see what this outputs, what the time is. Give us -1, trying anyway. Interesting. Okay, so there's different times. Of course, higher means faster and lower means slower. Maybe it's hanging, so I'm just going to stop it and just know that you can use different times for your Nmap scans. And that is it for today's workshop. Thank you guys for attending, and I hope you guys learned something and specifically learn how to use Nmap for auditing your own network. So thank you guys, and let me go. Do you guys have any questions? Okay, I'll
I don't
see.
have any.
Okay, thank you, Solomon. So I'll see you guys next time. Please like and subscribe.